So for the very first lesson, we're going to just basically do an introduction to quadratic functions and what the graphs would look like. So you are not going to have to do any graphing today. I think that's tomorrow. But we're going to go through all the different pieces of the graph. So that way you guys can identify like what's the domain, what's the range, what's the vertex, and everything else that comes along with each quadratic function. Okay, so a quadratic function, you guys will see it's going to look like this. You will always have a squared term, like x squared, m squared, whatever the letter is. That makes it quadratic, and every time you have a quadratic, your graph is going to look like a U-shaped graph, which is called a parabola. Okay, and then every single time you guys do one of these, you are probably going to be asked for domain and range. Okay, so your domain, and this is taught actually in like pre-algebra, domain is always based on your x values. So when you guys have to plug in x values up here, you're allowed to plug in any number you want to. Like I could plug in 0, I could plug in -5, it doesn't really matter. I can plug in anything. So if I ever ask you for the domain of a quadratic, your answer is always the same. It is always going to be all real numbers. Okay, now you know, I don't like to write all real numbers out. So what I typically do, there are two things you can do. You can make that like fancy capital R. It's really just a capital R with a second line through it. This symbol means all real numbers. The other way you guys are going to see this written, and I don't know how good you guys are at making infinity symbols. You all know what the infinity symbol looks like? So it's negative infinity to positive infinity. That covers every single negative number, positive number, and 0. So you can say all real numbers, you can make this symbol, or you can write it this way. Majority of the time, you guys are probably going to see me write it with the negative infinity to positive infinity. I'm not grading on how your infinity symbol looks like, or what it looks like. Just make sure I can tell that's what it is. And then your range, since domain is based on your x values, your range is always determined by the y values. So we're allowed to plug in anything we want to for x, but that is not true about y because y is the output. So your y, your range, is going to have two options. You are going to write y is greater than or equal to, or you're going to have y is less than or equal to. And then there will be some number over here, and I'll tell you later how to figure out what that number is. But the way to figure out whether it's greater than or less than, if the U-shaped graph is facing up, so like this one up here, if it's facing up, you're going to be using the greater than symbol. Okay, so this is for the one that faces upward. And then if it's less than, your U-shaped graph will face down. Okay, so that's how you know whether to use the greater than or less than. But you have to always include the letter y, and then like I said before, there will be some number over here. We might as well go ahead and write that down. So the number over here is going to be the y coordinate of the vertex. And I definitely suggest anything that I am writing down on here, you are going to want to write down, because you're going to be able to refer back to these notes when you're doing the practice page. You can't use the notes for your test. You will make your own page of notes for the test. All right, then down here at the bottom, they tell you this word parabola again. That's just the shape of the graph. That's what we call any U-shaped graph is a parabola. And your axis of symmetry, if you guys think about shapes that are symmetrical, what that means is if you were to draw a line down the center, and you were to fold it over, they'd be mirror images of each other. So the axis of symmetry, I'm not always the best at like sketching a parabola, but if I were to draw like a U-shaped graph right here, my axis of symmetry would go through this low point, and I always make it a dashed line because technically that's not really part of the graph, so I wouldn't make it solid. I make it dashed, but that line is what would cut that parabola in half. So if I were to fold this sheet of paper along that dashed line, this right here would fall right on top of that. They're mirror images, okay? So you'll see me put like AOS, that's axis of symmetry. And then your vertex is always going to be written as an ordered pair. So you'll have like an X comma Y for your vertex. And it's either going to be the high point. So see how this parabola is facing down? My vertex is located up there at the top. So this point right here is my vertex. If it's facing up, then it's the low point of the graph. But that would be your vertex. So wherever, it's the point where it changes direction, essentially. Is everybody okay so far? You have all those notes written down? As long as you have those written down, go ahead and turn the page for me. Okay, so at the top of this page, there's an example right here. The one we're going to look at is this one over here. And what we're going to do, I'm going to draw in my vertex, like my vertex is going to be this low point. So if you guys could go ahead and just put a dot there. And then I am going to draw in the dash line that goes through that. So if I were to draw a dash line going through my vertex, again, that is my axis of symmetry. Oh, I can't see what I just did, can you? And this little table right here, we are going to write down all of these pieces that go along with this graph. So when you guys do your practice page today, that's what you're going to do. I'm going to give you some parabolas like this, and you're going to basically fill out this information. You're going to tell me where the vertex is located. You're going to tell me what the axis of symmetry is. You won't have to do symmetrical points, but you will have to do domain and range and probably the y-intercept. I can't remember what all they ask for, but I know it's going to be those for sure, and then I think the y-intercept. So first things first, with the vertex, I need somebody to tell me if you were to write this point as an ordered pair, what would it be? Make sure you put the x first and then the y. 1, negative 2. Yep, that's right. Some of you, it might have been a while since you've had to write an ordered pair, but the x coordinate always goes first, and then the y coordinate always goes second. So it's the 1, negative 2. Now that vertex is extremely important because it gives you two things. See this x coordinate right here, that 1? That right there is the number that goes with your axis of symmetry. So the axis of symmetry, you have to put x equals, and then you just write the x coordinate of your vertex, which is 1. So this would be x equals 1. It has to be an equation like that. So x coordinate of the vertex. Ooh, it's an x. And then for the symmetrical points, the 2 points that they've already plotted, if you guys look up here, see how there's a point here and a point here? Those two are symmetrical. If I were to fold it along that dash line, this one would land on top of this one. We're not going to use those because see how it's like more than 2? It's not a whole number, it's a fraction. This one is a fraction also. We don't know what they are. So I want you guys to look at this one over here. So if you look at 3 comma 2, where is it symmetrical over here? Like what would be the matching -1 comma 2? Yep. So those are symmetrical points because if you start at your axis of symmetry, so you guys might want to watch this, starting at the green line, this point right here is 2 spaces to the right, and this one is 2 spaces to the left. So they are the same distance from the axis of symmetry. That makes them symmetrical. Does that make sense? That is going to be really beneficial tomorrow when you guys have to graph these yourself. Today you don't have to, but tomorrow you will. All right, now for domain and range. I already said domain, it's the same answer every time. What is it? All real numbers. So I'm going to write mine as -infinity to +infinity. But you guys can make the fancy R, or you can just write out all real numbers. And then let's talk about range. Is this parabola facing up or down? It's facing up. So when it's facing up, you put y is greater than or equal to. Where did I tell you to get that number from? So it's the y coordinate of your vertex. So this vertex, again, comes in real handy because now this -2 is the number I would use for the range. So that number right there is the y coordinate of the vertex. Now the y-intercept, you just have to look at the picture. So if you guys look at the picture of the parabola right here, here's my y-axis. Where does that cross the y-axis at? -1. So how would I write that as an ordered pair? 0, -1. Good job. Yep. Anytime you guys have a y-intercept, the x should be 0. It should be 0 comma something. And then you just look at the picture. Look to see where it crosses the y-axis. And then really the only other thing that's on this set of notes that's of importance is down here at the bottom, if I were to give you a quadratic, I'm totally going to make these up, okay? So if you guys look down here at the bottom, if I said y equals 2x squared plus 3x plus 1. See how this first number right here is positive? If it is a positive leading coefficient, it is going to face up. So positive makes us smile. Okay, so this, they refer to this as the A value. So if your A value is greater than 0, meaning positive, then you should always end up with a parabola that looks like a smile. And then obviously this one over here is when the first number is negative. So if I had like -3x squared minus 4x, I don't even know if that would work, plus 2. The leading coefficient this time is negative, so this is the kind that you would know automatically should be facing down. So if the A value is less than 0, making it a negative number, it should look like a frown. The only reason you'll really use that is like tomorrow when you guys graph them yourself, if you graph it and you look at your picture and it's facing down, but then you look at the original equation, if it had a positive number out front, you know you messed up somewhere. Because if it's a positive number out front, it should face up. And if there's a negative number out front, it should face down. So it's a way to check yourself at the end. Okay? Are we okay? Okay. Then we're going to go ahead and we're going to do this last one together. Then I'm going to give you guys a practice page to work on before class is over. And then second part of class, it's going to be all Brandy and dual enroll stuff. All right, so first thing, which way is this facing, up or down? Facing up. Okay, I'm going to put a point, put a dot at the very bottom of that graph, because remember, that's your vertex. And then you might as well just get in the habit of doing this using your pencil, or if you have a pen, draw that dashed line through your vertex. You're going to have to do it tomorrow anyway. So we need the vertex. So the ordered pair of that bottom point. One, -4. Yep, so +1, -4. What? Oh, yeah, this is a 1, and then this is the -4. Okay. Now, I'm going to draw this arrow. The vertex helps you with axis of symmetry and range. So those are the two things. Like the axis of symmetry you get from the x-coordinate. Your range you get from the y-coordinate. So I'm going to go ahead and fill those in. My axis of symmetry, remember, is always going to say x equals a number. And that number is the x-coordinate, which was 1. And then for the range, we'll go ahead and get that one done. You start with y. If it's facing up, what's my symbol? Greater than or equal to. If it had been facing down, we would have put less than or equal. And then, what's the y-coordinate? -4. So again, you just get that from right there. So as soon as you know your vertex, you have two other answers, which is really helpful. Okay? Now the y-intercept. Y-intercepts should always start with 0. And now look at your y-axis. This right here is your y. Where does this parabola cross the y at? -3. Yep, so it's 0, -3. And then as far as the x-intercepts goes, there are two of them. A lot of times with parabolas, it will cross the x-axis twice. We're going to write those as ordered pairs also. If the y-intercept starts with 0, then my x-intercept should do what? They should end with 0. So my two x values where it crosses at, what are they? -1 and 3. So -1, 0, and 3, 0. Those are the two places that my parabola crosses the x-axis at. Domain, same answer every time. All real numbers. So however you want to write it. Either put all real. So here, I'll write all the options. You guys just choose whichever one you want. All real numbers, the capital R with that second line through it, and then the one that I'm going to use most often, -infinity to +infinity. This is the one I'm going to use for domain. but I'll accept any of them. I will tell you, if you're a dual credit student, like if you qualify for Math 136, you will need to make sure you're in the habit of writing it like this, for sure. So that's why I just try to get all of you guys to do it anyway, because then you'll do it when you're working on your dual credit stuff. Okay, now that's it as far as notes go for today. So I'm going to stop the video. I'll get it uploaded, but then I'm going to give you guys a practice page. And your practice page, you're just doing a couple of these. I'm going to give you a picture, and you're just going to pick out all the different pieces of it.